Hello and welcome back for the final segment of graphing rational equations. We are finally going to go ahead and sketch those graphs. We have our vertical asymptotes, our horizontal asymptotes, and our x-intercepts, and we are ready for this last part. So let's go look at problem 1. Alright, I have just one vertical asymptote, so I need to look at my behavior on either side of it. There's no x-intercept, so I don't have to worry about crossing my horizontal asymptote. Let's go ahead and choose some easy points. To choose one on this side, I'm going to try x equals 3. That is going to give me 3 over 3 minus 2, which is 3 over 1, or just 3. So my point is 3, 3, and I'm going to go ahead and graph that. I want to try another one over here just to be safe, and I'm going to try x equals 5, because that's going to give me some nice numbers. I have 3 over 5 minus 2, which is 3 over 3, or 1. So I'm going to go ahead and graph that. And I'm going to go ahead and sketch my curve on this side. I expect this curve to be mirrored over here, but just to be sure, let me try some numbers. I'll try x equals 1, which is going to give me 3 over 1 minus 2, or 3 over negative 1, which is negative 3. And now I'm pretty confident now just mirroring this other point, over 1 up 3 with, or over 3 up 1 with over 3 down 1, and sketching in this curve. I know that I'm approaching my asymptotes forever but never quite reaching them, so there are both of my curves. Next up, problem 2. First thing we need to be careful with here with problem 2 is this negative sign here. It didn't get us in trouble finding our horizontal and vertical asymptotes, but it is going to get us in trouble if we're not more careful here on sketching our graph. So I'm going to assign this negative sign to the numerator so that I don't forget it. Now we have two vertical asymptotes, so we need to try between them as well as on either side. I'm going to start with trying between them. So if I try an easy number between them, that would be x equals 0. So let's see what we get for x equals 0. That's going to give us negative 2 over 0 squared minus 0 minus 6, which is negative 2 over negative 6. Negative divided by negative is positive, so I have 1/3, and that's going to be right around here. We know that we have no x-intercepts and that we are going to approach these vertical asymptotes infinitely, so I can safely sketch my curve up here. And now I just need to check on either side of these vertical asymptotes. So let's try x equals 4, see what we get. That's going to give us negative 2 over 4 squared, which is 16, minus 4 minus 6. 16 minus 4 is 12, minus 6 is 6, which is going to be negative 2 over 6, or negative 1/3. So that's going to be around here somewhere. This is going to need to approach this asymptote and this asymptote, so I can safely sketch my curve in here. I still need this other side. I expect it to mirror this side, but let's just check a point over here. I can try negative 3. That is going to give me negative 2. Negative 3 squared is 9. Minus negative 3 is plus 3 minus 6. And that is going to give me 9 plus 3 is 12 minus 6. 12 minus 6 is 6, and that's going to be negative 2 over 6, which is negative 1/3. and so it's going to be right around here, a nice mirror. I know I have no x-intercepts, so I can safely sketch my curve in here approaching this asymptote. We'll move on next to problem 3. Alright, let's look at problem 3. We do have an x-intercept that we have graphed here. So let's look at where we would expect the mirror point to be, and that would be at x equals 1. So if we plug that in, we would have negative 3 times 1 minus 3 over 1 plus 2, and that would give us negative 3 minus 3, which is negative 6 over 3. That's negative 2. So we would expect that point to be here, and we'd expect to be able to graph our curve like this. And we're going to expect this to mirror across our asymptotes, but just to be sure, let us check x equals negative 3. That's going to give us negative 3 times negative 3 minus 3 over negative 3 plus 2. Negative 3 times negative 3 is 9, minus 3 is 6, over negative 3 plus 2 is negative 1. It's going to be negative 6. So we find negative 3, and we expect that to be here. Feel pretty confident now mirroring this. We are down 1, down 3, so right here. And we're approaching our asymptotes, so we're going to sketch our curve like this. One more problem to go. Last problem here. Let's get this graph sketched. We already know that we are up above our horizontal asymptote here, and we know we have to be approaching our vertical and horizontal asymptotes, so I'm going to sketch in here, and I'm going to sketch in here, and that leaves me with what is going on in the middle. So let's try x equals 0. If I plug in x equals 0, I have 0 squared, negative 0 squared, plus 16. And I have 0 squared minus 9, which is going to give me 16 over negative 9, which is negative 16 ninths, something between 1 and 2 negative. So we know that it is more negative than negative 1. It's down here somewhere, and we can go ahead and sketch our curve in here. We know there's no more x-intercepts, so there's our curve, and we have our sketches made. And there's our curve sketching for rational equations. We haven't yet looked at holes. So in our next video series, we will discover what it means to have holes in our equations and why they happen.